Hello everyone, I'm here Smriti. Welcome to Physics Fact with a new topic, that is microscope. What is the use of microscope? It is an optical instrument which forms magnified image of tiny objects. Basically, microscopes are four types. The basic level of microscope, that is simple microscope. Then second one, professional research based microscope, that is compound microscope. Our binocular, that is the third type microscope, that is called as stereoscopic microscope. And the fourth one, electronic microscope. By the help of electronic microscope, we got million times of magnified image. So let's go through one by one.
Simple microscope is consisting of a convex lens of small focal length which is used to see magnified image of teeny object. इसका मतलब हम जो सिंपल माइक्रोस्कोप की बात कर रहे हैं ये क्या है? It consists of single convex lens. एक convex lens है जिसका फोकल लेंथ बहुत कम है और इसका काम क्या है? It magnifies the image of small object. When we take its very small object, by the help of this magnifying lens or this convex lens, or you say as simple microscope, by the help of simple microscope, you can see the magnified image. See this image. Here the magnifying lens, which is commonly used in our daily life, which is used to magnify image of any object, and this too in our school or colleges in biology lab it is used to magnify any biological slips. Then how that simple microscope is working, we discuss in this chapter. Okay? Now, हम सब बचपन में ये स्कूल में पढ़े थे, अगर कोई ऑब्जेक्ट हमारी आंखों से 25 सेंटीमीटर पर है तो वो ऑब्जेक्ट हमें क्लियर दिखाई देगा. Take us that object AB जो कि हमारी आंखों से 25 सेंटीमीटर डिस्टेंस पर है. This distance is denoted by D. हम बचपन में ये पढ़े थे 25 सेंटीमीटर पर अगर कोई ऑब्जेक्ट है तो हमें वो ऑब्जेक्ट क्लियरली दिखाई देगा. वो छोटी ऑब्जेक्ट हमारे आंखों में जो एंगल क्रिएट करेगी उस एंगल को कहा जाता है एंगल सबटेंडेड बाय दिस ऑब्जेक्ट एंड डिनोटेड बाय अल्फा. ओके, बात को समझो. हम यहाँ खड़े हैं, हमारे आंखों से 25 सेंटीमीटर डिस्टेंस पर एक ऑब्जेक्ट हम लिया जो कि बहुत छोटी है, तो वो हमारी आंखों में कितनी एंगल क्रिएट करेगी? वेरी स्मॉल एंगल क्रिएट करेगी. उस एंगल को एंगल सबटेंडेड बाय दैट ऑब्जेक्ट, एंगल सबटेंडेड बाय दिस ऑब्जेक्ट ये कहा जाता है एंड डिनोटेड किया जाता है अल्फा से. हमने माना चलो भाई हम तो 25 सेंटीमीटर के डिस्टेंस पे ऑब्जेक्ट रख दिया, फिर भी हमें क्लियरली क्यों नहीं दिखाई दे रही है? बहुत छोटी है इसलिए दिखाई नहीं दे रही है. तो अब हम क्या कर रहे हैं, ये एक स्मॉल ऑब्जेक्ट था AB, हमसे 25 डिस्टेंस पर था. ओके, पर अब हम क्या कर रहे हैं, बाय द हेल्प ऑफ सिंपल माइक्रोस्कोप जब से हम ये ऑब्जेक्ट को देखते हैं तो क्या होता है, द एंगल सबटेंडेड बाय द इमेज that is large. Here that large view is produced. So the angle subtended, that angle is increases and this angle is called as angle subtended by the image A prime B prime. समझ आया? जो ऑब्जेक्ट हम लिए थे उसका लार्ज व्यू हमें मिला सिर्फ उसी डिस्टेंस पे, डी डिस्टेंस पे। सो ये जो हम सिंपल माइक्रोस्कोप लिए थे ये कैसे वर्क कर रहा है, किस तरह काम कर रहा है, इसके बारे में डिस्कशन करेंगे। और ये जो मैग्नीफाइड इमेज हम पाए ये कितनी मैग्निफिकेशन देता है, कितनी मैग्नीफाइड इमेज हम पा रहे हैं, इसके बारे में डिस्कशन करेंगे। समझ आ रहा है? Let's take that object AB nearer to the microscope. So, हमें किस तरह की इमेज चाहिए ना, मैग्नीफाइड इमेज चाहिए। तो ऑब्जेक्ट को कहाँ रखें तो मैग्नीफाइड इमेज मिलेगा, ये हम ऑलरेडी डिस्कस कर चुके हैं, ओके ना। When we take that object at center of curvature, we got that image same size as that of object. Within center of curvature and focus, we got magnified image, but that is real. That image is produced here. But if we take that object within focus, then we got magnified and visual erect image of that object. What is the characteristic of image? That is visual, erect and magnified. So we take that object within the focus. ठीक है? And that object is in between optical center to focus. This one is the optical center. Object is in between optical center and focus. So take us two ray, one ray which is parallel to the principal axis. After reflection goes through focus. Another ray which is goes through center of curvature. There is no deviation takes place. The two rays are diverges but appears to come from one point. So here image is produced. Take us, this one is the image. Take this image, that is A prime, B prime, and the characteristic of the image, that is visual, erect and magnified image. Okay? And here what happened? This one is the angle subtended by the image. This one is the angle subtended by the image, and that angle is denoted as beta. You clear, students? Here, angle subtended by object. That angle is taken as alpha. Angle subtended by image. That angle is taken as beta. And here is the eye, person's eye. Here person's eye can see the large image of this skinny object. Okay. Then how that image is magnified? Okay. What is the magnification of this simple microscope? We discuss in this topic. Magnifying power, or here we take as angular magnification. So what do you mean by angular magnification? It is the ratio of angle subtended by the image, angle subtended by the image to the angle subtended by the object at the eye. Then both object and image both are at least distance of distinct vision. Both are at least distance of distinct vision. That means देखो हम ये कह रहे हैं कि हमारे आंखों से अगर 25 सेंटीमीटर डिस्टेंस पर अगर कोई ऑब्जेक्ट है और वो बहुत छोटी है तो हमें बहुत स्मॉल दिखाई देगा, मैग्नीफाइड और क्लियर विजन नहीं दिखाई देगा। समझ आ रहा है? सेम उसी ऑब्जेक्ट को हम देख रहे हैं with the help of microscope. An image is also produced at the distance from the eye. From eye to image, that distance is also 25 centimeter. So यहाँ पे जो एंगल क्रिएट हो रहा है इन दोनों एंगल denoted by m. M equals to the angle subtended by the image to the angle subtended by the object. What is the angle subtended by the image? That is beta. What is the angle subtended by the object? That is alpha. But what happened? That object and image both are at least distance of distinct vision from us. हमारी आंखों से 25 सेंटीमीटर की दूरी पर both object and image रहना चाहिए. Take us that beta and alpha that are very small angle. Beta and alpha that are very small angle. So we take that tan beta and tan alpha. Tan beta and tan alpha. What is tan beta? This one is P, this one is B, and this one is X. So what is tan beta? A prime B prime by this distance. What is this distance? This distance is the least distance of distinct vision, that is denoted by D. So tan beta equals to A prime B prime by D. Then what is tan alpha? Tan alpha, that is AB by this distance. So what is this distance? That is also same 25 centimeter. AB by D. तुम लोग समझ रहे हो ना ये क्या हो रहा है? हम ऑब्जेक्ट को 25 सेंटीमीटर से देख रहे हैं. हमें लगा ओके भाई ये तो स्मॉल दिख रहा है, तो माइक्रोस्कोप की हेल्प से देख रहे हैं. विद द हेल्प ऑफ माइक्रोस्कोप जो इमेज प्रोड्यूस हो रहा है वो भी हमारी आंखों से 25 सेंटीमीटर डिस्टेंस पर ही बन रही है. m equals to tan beta by tan alpha, that is equals to tan beta, that is A prime B prime by D, by tan alpha AB by D. So A prime B prime by AB, D cancel, that is A prime B prime by AB. That means height of image divided by height of object. यहाँ पे देखो, this one is the height of image and this one is the height of object. We know that height of image divided by height of object, that is linear magnification, that is equals to V by U. Yes. So यहाँ पे V क्या कौन सा है और U कौन सा है? ये हो गया हमारा U और ये हो गया हमारा V. यहाँ this one is object distance and this one is image distance. समझ आ रहा है? So यहाँ हम V के जगह D लिख सकते हैं या नहीं? लिख सकते हैं D by U, because image तो यहाँ प्रोड्यूस हुआ है कितनी डिस्टेंस पर? D डिस्टेंस पर. ओके, सो D by U. जब हम मैग्नीफाइंग लेंस यूज करते हैं तो हम क्या करते हैं? मैग्नीफाइंग लेंस को ऐसे पास में लेकर जाते हैं, है या नहीं? पास में लेकर जाते हैं. दैट मींस ये ऑब्जेक्ट है और ये रहा मैग्नीफाइंग लेंस, इन दोनों के बीच डिस्टेंस बहुत कम होता है जो कि ऑब्जेक्ट डिस्टेंस है, दिस वन U. So when image is produced, at which distance image is produced? That image of this object is produced behind the object. यहाँ पे object है तो image इसके पीछे प्रोड्यूस हो रहा है. Image is produced behind the object. Okay, so this one is the image distance. So what is magnification? That magnification equals to D by U. That is the general concept, that magnifying power, that m equals to D by U. Now we go to discuss two cases. Case 1, case 2. What is two case? अरे भाई मैग्नीफाइंग इमेज तो पहले, फिर एक केस क्या है? कंडीशन क्या है? कंडीशन है. क्या कंडीशन है? देखो, एक कंडीशन ये होता है हमें इमेज नियरर में चाहिए. सेकंड कंडीशन, इमेज इंफिनिटी में प्रोड्यूस होगा तो भी चलेगा. टू कंडीशन. एक कंडीशन, इमेज हमें नियरर में चाहिए, नियरर टू आई. इमेज इज नियरर टू आई. सेकंड कंडीशन में इमेज प्रोड्यूस एट इंफिनिटी. इमेज प्रोड्यूस एट इंफिनिटी. देखो, हम हमारे हाथ को ऐसे जाएंगे तो आप हमारे हाथ को क्लियर से देख सकते हो और आपके आई में कुछ प्रेशर भी नहीं होगा। सो ऐसे ही हम जब इमेज को इंफिनिटी से देखते हैं, इमेज को इंफिनिटी से देखते हैं, ओके, जब हम इमेज को कहाँ देखते हैं, इंफिनिटी पे देखते हैं, हमारे आंखों के ऊपर भी कोई प्रेशर नहीं आता है, हमारे आंखों को कोई प्रेशर नहीं पड़ता है, तो गॉट लेस स्ट्रेन। हम कुछ इस तरह के यहाँ सेटअप कर लेंगे जिसकी वजह से ये इमेज इंफिनिटी पर प्रोड्यूस होगा, ये इमेज इंफिनिटी पर प्रोड्यूस होगा। समझ आ रहा है कैसे सेटअप करेंगे, ये हम डिस्कशन करेंगे। ये इमेज जब इंफिनिटी पे प्रोड्यूस होगा तो क्या होगा, आई के ऊपर कोई भी प्रेशर नहीं रहेगा and it is most suitable and relaxed eye vision that image is produced at infinity. So second condition क्या है, that image is produced at infinity for suitable and comfortable, suitable and comfortable relaxed eye vision. Clear students? Case 1. So यहाँ इमेज प्रोड्यूस हो रहा है at least distance vision, that means nearer to eye and at a 25 centimeter distance from eye, okay, the d equals to 25 centimeter. So यहाँ magnification क्या होगा, magnifying power of this simple microscope क्या होगा, हम डिस्कस करेंगे एंड फार्मूला डिराइव करेंगे। we know that lens formula, that is 1 by v minus 1 by u is equals to 1 by f. Yes. So यहाँ पे u क्या है, u क्या है, साइन कन्वेंशन यूज करके u क्या है माइनस u, v क्या है that is d, that is minus d, and f क्या है that is this one, this distance is focal length f. Yes. Put all the sign convention here. For convex lens, focal length is always positive. Okay. Put all the sign convention here. Then we got 1 by minus d minus 1 by minus u equals to 1 by f. Okay. Then this one equals to 1 by d minus minus plus 1 by minus by 1 by u equals to 1 by f. Multiplying d both sides, multiply d both side, then what we got, d multiply कर दो both side में तो d by d ये cancel हो जाएगा -1 plus d by u equals to d by f. Okay, d by u, what is this, d by u is the magnification, angular magnification. So here in case of d by u we put m equals to, that is d by f and 1 go to this side, now m equals to 1 plus d by f, m equals to 1 plus d by f. So here what we got, that when that image is produced at least distance vision from us, that this one is the magnifying power. As focal length of the lens, as focal length of the convex lens is minimum, magnifying power is maximum. Okay, here the condition, जितना focal length minimum होगा, okay, minimum focal length जितना minimum होगा, magnifying power माइक्रोस्कोपिक उतनी ज्यादा होगा, क्योंकि focal length minimum हो गया मतलब पावर जो है, पावर लेंस का पावर उतना ज्यादा बढ़ जाएगा, क्योंकि p इक्वल्स टू 1 by f, फोकल लेंथ जितना कम हुआ पावर उतना ज्यादा होगा, मैग्नीफाइंग पावर भी उतना ज्यादा होगा। और यहाँ पे इस 25 डिस्टेंस विजन पर हम जो इमेज पाएंगे मैक्सिमम मैग्नीफाइंग पावर होगा, मैक्सिमम मैग्नीफाइंग power. Then we go to the second case. Now go to case 2, that image is produced at infinity. इंफिनिटी पे कब इमेज प्रोड्यूस होगा, जब ऑब्जेक्ट फोकस पर होगा. ओके, हम कुछ ऐसा सेटअप करते हैं कि ऑब्जेक्ट को हम कहां पे रखते हैं, ना फोकस ऑफ दिस convex lens. Okay, we set up that object or place the object at the focus of this convex lens. So obviously that image is produced at infinity. Either that image is produced here, either that image is produced here. Okay, or either image is produced here, but image is produced far away from us. Image is produced at infinity means far away from us. Okay, now here we take if image is produced here. Okay, the two they meet here and image is produced here. That is A prime, B prime. Okay, take as image is produced here. So this ray is meet here. So this angle is angle subtended by the image. Angle subtended by the image, that is beta. Here also we calculate or we take the ratio of angle subtended by the image to the angle subtended by the object. M equals to beta by alpha. Okay, image is produced at infinity. Okay, that means image is far away from us. Here image is at least distance of distant vision, but here image is far away, infinity distance from us. Far away from us. So M equals to beta by alpha. We take that angle subtended by the image to the angle subtended by the object, beta by alpha. Then what is tan beta? The tan beta equals to tan beta, that is equals to A prime B prime by this distance. Instead of A prime B prime by infinity, we return that AB by F, because then in angle is same for this image, also for this object. So see in this diagram, ये जो एंगल क्रिएट हो रहा है ये इस इमेज के लिए और इस ऑब्जेक्ट के लिए सेम हो रहा है या नहीं. So instead of A prime B prime by infinity, we take as AB by F. So tan beta equals to, here tan beta equals to AB by F. You simply remember AB by F. Okay, AB by F. F, this one is the focal length. And tan alpha, we know the tan alpha, that is AB by this distance. AB by this distance of distant vision D. So M equals to what happened? Tan beta by tan alpha. That means AB by F divided by AB by D. AB cancel. So what is M? Magnification. That M equals to AB cancel. So M equals to D by F. Okay, M equals to D by F. So in general formula we got that M equals to D by U, least distance of distance vision by object distance, if image is produced at least distance of distant vision, that means image is produced at 25 centimeter, then magnifying power M equals to 1 plus D by F. If image is produced at infinity or far away from us, then magnifying power M equals to D by F. And this magnifying power is the minimum magnifying power. This one is the minimum magnifying power. Minimum magnifying power of a lens. Okay, this one is the greatest magnifying power or maximum magnifying power, and this one is the minimum magnifying power. Okay, students, I think you all clear about it.